Hello, is my screen visible?
Yes, please.
Okay, thank you. Okay, so good evening everyone. I am Riya Kapwal. I am doing my PhD under the supervision of Professor Sudeep Mishra at IIT Kharagpur. Today we will discuss the topics of week 11 and after that we will discuss some questions. So last week we discussed about smart homes and smart cities, and today we will continue with smart grids. So basically smart grid is conceptualized as a planned nationwide network that uses information technology to deliver electricity efficiently, reliably and securely. So basically it uses the network or the internet in order to transmit the electricity. So what that this exactly mean? So is it sending the electricity through network or what? So basically it means it is using the network of your sensors, actuators in order to check or determine the usage of power by various users and the amount of electricity that is generated at your power grid. Smart grid is also named as electricity with a brain, the energy internet and the electronet. So according to NIST, smart grid is a modernized grid that enables bidirectional flows of energy and uses two-way communication and control capabilities that will lead to an array of new functionalities and applications. As you can see in this picture, the electricity is transmitted from this power generator to various homes where different appliances are using the electricity, and there is two-way communication taking place between the different appliances as well as the grid with the help of your network. Now the benefits of using or the benefits of smart grids. So basically it is more in smart grid there is more efficient transmission of electricity. The next is there is quicker restoration of electricity after power disturbances. Then reduced operation and management cost for utilities and ultimately lower the power cost for consumer. Next is a reduced peak demand, which will also help lower electricity rates. Then the increased integration of large scale renewable energy systems, better integration of customer owner power generation system including renewable energy systems, then improved security. After that, using smart grid, both consumer and energy service providers will get benefited. So basically in a smart grid, as you are using sensors and actuators in order to monitor the use of electricity and further the amount of electricity that is generated. So with the help of this we can, by using that data and performing analysis over that data, we can get an idea that the amount of electricity that can be needed in the future. So on the basis of that analysis, we can set the prices also. We can provide energy or power to the users on the basis of their demands also. So due to this, if there is some power disturbance, we can redirect the users to some other power grid. So basically it will lead in better management of electricity. Now this is the conceptual model of smart grid. So basically this diagram is showing the communication that is taken place between different components, that is your market, operation, service provider, customer, distribution, generation and transmission. So the electricity is distributed between your transmission unit, distribution unit, customer and generation, and these blue lines are the communication that is taking place between these different components. After that, the properties of smart grid. So first property is consumer participation. So in case of smart grids, there is complete consumer participation. So basically the end users can get to know that how much electricity they are using. There is real-time monitoring of power consumption. Then after that, with the help of their mobile phone only, they can control their smart appliances, and there is complete automation of their smart homes with the help of their mobile phone only. So basically smart grid is responsible for building complete automation. Next is real-time pricing. So real-time pricing means on the basis of demand of power or electricity, the service provider can set the price of electricity. For example, in off time electricity requirement, the pricing will be low, and for the on time demand, the pricing can be set as high. After that, distributed generation. So in case of smart grids, various microgrids are interconnected with each other in order to generate the electricity. Further, these are also interconnected or integrated with your renewable energy resources in order to generate the electricity. Next is your power system efficiency. So basically there is complete power monitoring, asset management, and there is proper utilization of electricity, which results in complete distribution, automation and protection. Next is power quality. So in case of smart grid, there is self-healing capability. Further, frequency monitoring and control is there. Then load forecasting is there. Anticipation of disturbances can be done with the help of analysis that is done on the data which is collected with the help of sensors. Now the components of smart grid. So basically these are the 6 main components of smart grid. First one is your smart home, and the next one is renewable energy, then consumer engagement, operation center, distribution intelligence, and plug-in electric vehicle. Now we will discuss these one by one. So first one is your smart home. So smart home uses emerging smart grid technology in order to save energy. Smart home uses emerging smart grid technology in order to save energy, which seek out the lowest rate and contribute to the smooth and efficient functioning of electric grid. Further, the interactive relationship between the grid operator, utilities and consumer helps in proper functioning of smart grid technology. Then the computerized control in smart homes helps to minimize the energy use at times when power grid is under stress from high demand, or even to shift to some other power use to times when power is available at lower cost. that is on peak hours to off peak hours. So basically with the help of computerized control or with the help of your mobile phones, you can control the appliances that are using electricities in your smart home, and with the help of which you can also shift their usage from on peak hours to off peak hours. Next is renewable energy. So according to International Energy Agency, renewable energy is derived from natural processes that are replenishing constantly. Then in its various form, it derives directly from the sun or from the heat generated deep within the earth. Included in the definition is electricity and heat generated from solar, wind, ocean, hydropower, biomass, geothermal resources, and biofuel and hydrogen derived from the renewable resources. So it reduces the environmental pollution, and the consumers are capable of generating energy from renewable energy resources, are less dependent on the microgrid or the main grid. So basically they are generating energy with the help of renewable energy resources. So the energy which is generated from the microgrid is not used in this case. In addition to that, they can they can supply surplus amount of energy from the renewable resources and can make profit out of it. Next component is consumer engagement. So consumer can save energy with proper scheduling of smart home appliances. So basically so with the help of mobile phone, you can schedule that at what time which appliance is going to use the energy and what is not, which is not. Then the users have to pay less for consuming the energy in the off peak hours. So basically for the charging of their appliances, they can schedule the charging of appliances in the off peak hours. So basically whenever they will charge their devices in the off peak hours, they have to pay less for that energy they are using. Then energy service providers give incentives based on the energy consumptions of consumer, and they can save money. Next is consumer involvement can be in the following ways. So first is time of use pricing, next is net metering, and last one is financial incentives. The next component is operation centers. So basically first of all we will discuss the drawbacks of traditional operational centers, and after that we will discuss about smart grids. So the grid is in case of your traditional operation center, the grid is unstable if the grid voltage drops due to excess energy generation. Next is limited control capabilities. So in case of your traditional operation center, the control capabilities are less as compared to your smart grid. Then there is no means to detect the oscillation which leads to blackouts. So basically in case of your traditional operation center, there are no sensors which can detect the amount of energy that is being used at a particular amount of time. So with the help due to this, we cannot detect the frequency or the voltage that is being used at a particular amount of time, and we cannot detect whether there can be a blackout at a particular time or not. Then limited information about the energy flow through the grid is there in case of your traditional operation center. However, in case of your smart grid, it provides information and control on the transmission system. It makes energy grid more reliable and minimize the possibility of widespread blackouts. Now the distribution intelligence. So distribution intelligence means the energy distribution systems which are equipped with your smart IoT devices. So along with your smart meters, distribution intelligence can also identify the source of power outage. It also ensures the power flow automatically by combining automated switching, and it also optimizes the balance between the real and the reactive power. Now what does this reactive power mean? So basically the the device that store and release energy. So basically the energy which is stored and released by the device is your reactive power, and it can cause increased electrical currents without consuming the real power. Next is your intelligent distribution system maintains the proper level of reactive power in the system and protect and control the feeder lines. The next component is your plug-in electric vehicle. So smart grids have the infrastructure needed to enable the efficient use of plug-in electric vehicle. So with the use of plug-in electric vehicle, the dependency on the oil will get reduced, and there is no pollution when the vehicles are running on electricity. Further, your public electric vehicle rely on power plant to charge their batteries, and energy service provider encourages the customer to charge their batteries of plug-in electric vehicles in the off-peak hour. So PEV also can be used as an energy source in the on-peak hours. So basically, whenever there are on-peak hours, the grid can also take energy from plug-in electric vehicle. So in starting figure, I have discussed that there is two-way flow of energy. So basically here, from the power grid, electricity flows from the power grid to your plug-in electric vehicle, and vice versa is also taking place. So in the case of your on-peak hours, the electricity can also flow from your plug-in electric vehicle to the power grids. After that, PEV get incentives from energy service provider for providing energy to the grid through discharging. So whenever they are transmitting energy or electricity to your power grid, they are getting incentives for that. Now next is the communication, smart grid communication. So the components for smart grid communications are smart home appliances, smart meters, gateways, data aggregator units, and meter data management systems. Basically these are the components responsible for the communication. Now smart meters and gateway. So each gateway connect few closely located smart meters. So gateway communicate mostly by using Wi-Fi or IEEE 802.11, and gateways helps in two-way communication. So gateways are responsible for connecting various smart meters. Now smart meters forward the energy consumption information from the home appliances to the gateways, and forwarding the billing amount and the control information from the gateways to home appliances. Gateway act as a link between the smart meters and the data aggregator unit. Now what is data aggregator unit? So it aggregates the energy consumption or energy request from certain geographical area and forward the energy consumption information to the centralized coordinator, that is your meter data management system. And it also maintains a buffer to queue the energy consumption information of the consumers. Now meter data management system. It acts as a centralized coordinator for smart grid communication. It is handled by the energy service provider, and it is a part of operation center. It decides the price per unit energy to be paid by the consumer. So basically the centralized coordinator is your meter data management system, which is further connected with your data aggregator unit, which are connected to your gateways, and gateways are further connected to the smart meters. Now different networks that are associated with smart grid communications are home area network, neighborhood area network, wide area network, IP networks, and sensors and actuator networks. Now these are the protocols which are available for smart home appliances, such as your C-bus, DECT, N-Ocean, Universal Power Line Bus, Thread, Zigbee, simplified cable solutions. So these are some protocols and their features are given here. Now the security. So smart grid is a cyber physical system, and there are various vulnerability involved in smart grid. So first one is your integrity. So integrity means the credibility of data collected and transferred over the grid. Next one is your availability. So it is defined as the accessibility to every grid component as well as to the information transmitted and collected. Next is your dynamic system attacks. So based on the previous information, same type of request can be replicated by the attackers. Next is physical threats. So physical attack to the grid component and the coordinated attack. So cascading failure of system in smart grids are your coordinated attacks. Now smart grid and cloud applications. So in order to manage the data which is generated by your smart grids, and in order to provide various services to the consumer, it is better to integrate the smart grid with your cloud. So in smart grid, cloud applications take a lead in several aspects. For example, in your energy management, information management, and in order to provide security to the data. Now the energy management in smart grid can be more efficient with the help of cloud computing, because we can use different services which are provided by the cloud, and integrating cloud computing applications for microgrid management in the form of different modules such as your infrastructure, power management and service. So information processing in smart grid fit well with computing and storage mechanism which are available for cloud application. Now the information from different components and supply and demand state conditions can be shared with the help of cloud computing. So basically, for your energy management, for sharing the information and for storing the information in secure manner, your cloud computing can be integrated with your smart grid. Now this diagram is showing that how different units of smart grids are interconnected to the customers, and further their data is shared with further cloud. Now the next topic is industrial internet of things. So industrial internet of things, that is your IIoT, is an application of IoT in industries to modify the various existing industrial systems. So basically it means to use the IoT devices in your industries. So IIoT links the automation system with enterprise planning and product lifecycle. So basically this diagram is showing that your industrial internet of things is the integration of your internet of things and industry 4.0. So basically industry 4.0 means the automation of your industries. So it consists of various sensors, actuators in order to automate the industry. Then after that, using analysis and processing power also. So all those things comes under your industry 4.0. Now internet of things means using sensors and actuators in order to control the devices and in order to take the data or sense the environment. Now to use those devices in your industry 4.0 will make IIoT. Now IIoT includes machine learning, big data technology, machine to machine interaction and automation. IIoT is supported by huge amount of data collection from the sensors. It is based on wrap and reuse approach rather than rip and replace approach. Now this figure is showing that how your internet of things is different from your industrial internet of things. So basically industrial internet of things means your enterprise internet of things. So internet of things which are used in an industry is your industrial internet of things. So your IIoT is more related to your machines, the interaction that take place between the machines, and your normal IoT is more oriented towards your normal consumers. Now, IIoT is a network of physical objects, systems, platforms, and applications. So, basically, this figure is showing that in case of your IIoT, industries, your normal traditional industry can be integrated with your industry 4.0, that is the automation, and further can be integrated with cloud in order to provide various services and processing capability to your enterprise. Now, IIoT requirements. So first one is your big data analytics. So there is a need to analyze the data which is generated by different sensors. Then second one is your hardware and software connectivity. So there should be proper connectivity between different devices or various hardware and software that are in your industries. Then application development, and there should be a cloud platform which is going to manage the data or organize the data which is produced by different applications. Now, this figure is showing that what are the different aspects that we can consider in your industrial internet of things. So there should be end-to-end security, there should the user experience should be good, there should be transition to smart machine, asset management should be there, big data is involved, then cloud for efficiency and agility is there, and after that access to the data or anything or any type of services from anywhere and anytime should be there. Now the design requirements. So to use an IoT device for industrial applications, the following design objectives are to be considered. So first one is your energy. So time for which the IoT device can cooperate with limited power supply. Then second is latency. It is defined as the time required to transmit the data. The next parameter is throughput. So throughput means the maximum data that can be transmitted over the network. Next is your scalability. So scalability means the number of devices that can be supported. Next is topology. So the communication or the arrangement of different devices among is your topology, and further in topology the interoperability is also a subpart. So basically the devices which are communicating with each other should be interoperable also, so they should be able to understand the meaning of messages which are exchanged. Then the safety and security. So the degree of safety and security of the application should be there when you are going to design the IIoT application. Now these are the differences between your IoT and IIoT. So IoT focus on convenience of individual, however your IIoT focus on efficiency, safety and security of the operation. Now in case of your IoT, in case of IoT, machine to machine communication is limited. However, in case of your IIoT, machine to machine communication is extensive. Then application areas are at consumer level in case of IoT, and in case of your IIoT, application areas are at industries. Now this diagram shows that for your machine to machine communication, it majorly focus on devices, connectivity, service enablement and application and data. However, IoT focuses more on network, service enablement and application and data and system integration. Next is your service management in IIoT. So service management refers to the implementation and management of the quality of services which meets the end user demands. So service is the collection of data and associated behavior to accomplish a particular function or feature of device or a portion of device. Now services can be of two types. First one is your primary service and second one is your secondary service. So basically primary service means the basic service which are responsible for the primary node functions, and secondary services are the services which provide services to your primary service. So basically, in order to give rough idea about the primary and secondary services, these are some examples. So you can consider healthcare, education, banking, retail, transportation as a primary service which are required to a human. However, there are some services which are required by these primary services. For example, the maintenance of data, marketing of product, accounting, customer services. So these services can act as secondary services. Now the applications of IIoT. So the key application areas of IIoT are manufacturing industries, healthcare, service industry, transportation and logistic, mining and firefighting. Now the challenges. So the first challenge of IIoT is worker health and safety. It is the most important thing that is required in your industries. The next one is your regulatory compliance. Then environmental protection should be there. Optimized operations should be there. Then after that, in the second figure, the issues which are related or the challenges which are related to environment are given. So handling and storing or using hazardous substances. Next one is your oxygen deficiency is there. Then industries also results in the release of particulates. Then sometimes there is emission of radiations also. Then physiological stress is also there in your industries. Now the risk associated with IIoT in manufacturing. So though IIoT provides new opportunities, but few factors may cause hindrance in in its path, which are lack of vision and leadership is there, lack of understanding of values among the management employees is there. Then the sensors which are used are costly. Then the infrastructure is inadequate. So these are some challenges or the risk which are associated. Then how to meet those challenges. So basically, manufacturer use software capabilities in order to improve operational efficiency through predictive maintenance, savings on scheduled repair, that reduce maintenance cost, reduce number of breakdowns. So basically, in case of your IoT, as sensors are used, so with the help of these sensors, predictive maintenance can be done. It can be known that when your device is going to be fail. So if that is pre-known, then we can schedule their repair, and with the help of this we can prevent large amount of money, which can be used further in other places. So it also results in reducing the maintenance cost and the number of breakdowns, which can result in various losses. Now the benefits and research trends of IIoT. So these are the benefits. First one is your improved connectivity among the devices is there, improved efficiency is there, then upgraded scalability. It reduces the operation time also. Remote diagnosis can be done with the help of IIoT. Then it is more cost effective as compared to the traditional way or the traditional enterprises. Now the recent research challenges in IIoT are to improve the communication among the different devices or different things or objects, to develop energy efficient techniques, so to reduce the power consumption by the sensors, to develop context aware IoT middleware for better understanding of sensor data, to create smart objects with larger memory, processing and reasoning capabilities. So these are some research challenges over which various researchers are working on, and they are proposing various different kinds of solutions. Now, data handling and analytics. So data handling ensures that research data is stored, archived and disposed of in safe and secure manner during and after the conclusion of research projects. It includes the development of policies and procedures to manage data handled electronically as well as through non-electronic means. In recent days, most data concerns are big data due to heavy traffic generated by the IoT device and huge amount of data generated by the deployed sensors. Now, what is big data? So, big data technology describes a new generation of technology and architecture designed to economically extract value from very large volumes of wide variety of data by enabling high velocity capture, discovery or analysis. So, it is the definition given by IDC, that is your International Data Corporation. Then next definition is given by NIST, that is National Institute of Standard and Technology. According to NIST, big data shall mean the data of which the data volume, acquisition speed and data representation limits the capacity of using traditional relational method to conduct effective analysis, or the data which may be effectively processed with important horizontal zoom technologies. Now the types of data. So basically the data is categorized into two categories. First one is your structured data and second one is your unstructured data. Structured data means the data that can be easily organized. So it usually stored in relational databases. SQL can be used in order to manage the structured data, or it accounts only for 20% of the total data which is available in today's world. So basically the data which can be stored in your spreadsheets or Excel or in your SQL databases is your structured data. However, unstructured data, the information that do not possess any predefined model, is your unstructured data. So traditional RDBMS are unable to process your unstructured data. It enhances the ability to provide better insights to huge data sets, and it accounts for 80% of the total data which is available today. So the examples of your unstructured data are your audio, video data. Now the characteristics of big data. So big data is characterized by 7 V's. So 7 V's stand for volume, velocity, variety, variability, veracity, visualization and value. So basically volume means the amount of data which is generated. Velocity means the frequency at which the data is generated. Then the variety is the heterogeneity or the different types of data which is generated. Give me 2 minutes, I am getting a call. We were discussing about variety. So variety means the different types of data that is available. Then the variability. Variability means, okay, so for variability you can consider an example. So it is basically in case of variability, consider a coffee shop that may offer different blends of coffee, but if you get the same blend every day and it tastes different every day, that is variability. So basically, for example, consider you are ordering cappuccino daily and you are getting different taste of same coffee, then it is variability. Now the variety of coffee can be different, okay, so it can be cappuccino, it can be black coffee, latte, so different type. So this is variety. Variability means same type but you are getting different taste, so that is variability. So it can so in case of data, it can be due to some noise or uh, uh, so due to some noise or interference, so these can leads to variability. Now next is your veracity. So veracity ensures that whether your data is accurate or not, which requires the processes to keep the insufficient data from accumulating in your system. Next is your visualization. So with the help of various charts or graphs, you can visualize same data in different forms. The next one is your value. So value means the the data source from which you are getting the data. So basically it tells the amount of efforts or resources or the time through which you are getting that particular data. Now data handling technologies. So first one is your cloud computing. So with the help of cloud computing, you can manage and handle data. So the essential characteristics of cloud computing, we have already discussed this. First one is your on-demand self-service. Next one is your broad network access is there, resource pooling is there, rapid elasticity is there, then measured service is there in case of your cloud computing. Then the three models of cloud computing, first one is your infrastructure as a service, platform as a service, and software as a service. So we have discussed these models in very detail. Next one is your Internet of Things. So for collecting data from environment, Internet of Things can be used. So various sensors are embedded into various devices or machines, and these sensors are responsible for collecting data and further transmitting the data to the remote servers or internet, over which some analysis is performed. Now data handling at the data center. So it means storing, managing, and organizing the data, which estimates and provides the necessary processing capacity. It also provides sufficient network infrastructure, which effectively manages the energy consumption. It also replicates the data to keep backup and develop business oriented strategic solution from big data. It helps businesses to analyze existing data and discovers the problem that are existing in business operation. So basically this figure is showing the various phases that are involved in your data. So first phase is generation of data. After, so various enterprise data, IoT data, or biomedical data, different types of data is there. Then after that, once the data is generated, we need to collect the data. So that phase is called your data acquisition. So data in this phase, data collection, data transportation, and data pre-processing is done. The next phase is data storage. So for data storage, various technologies such as your Hadoop, MapReduce, NoSQL databases are used. And then analysis. So further, once the data is stored, various analysis can be done on that data. So various technologies can be used in order to analyze the data. For example, your Bloom filter, parallel computing, hashing and indexing, your machine learning algorithms can be used. So there are different techniques available in order to analyze the data. Now the data source. So these are different data source. I have already discussed that it can be your enterprise data, that is your online trading and analysis data, production and inventory data, sales and other financial data. Then data can be your IoT data, that is the data from industries, agriculture, traffic, transportation, medical data, data from public departments and families. Data can be your biomedical data and from other fields also, for example computational biology, astronomy and nuclear research. Now these are the other phases. I have discussed these in the figure only. So this is the same data storage. Okay, now the questions. Okay, before starting questions, let's take a break of 5 minutes, and after that we will start. Yeah, next week we will have two sessions. One will be on Friday from 6 to 8, and the other one will be on Saturday 5 to 7. So, on Friday we will discuss about the week 12 only, and on Saturday we will discuss some questions which are relevant for your exam. Those questions will be from week 1 to week 12. Okay. Okay, let's start. So, first question is, which of the following is true about traditional electric grid? Options are monitoring and restoration is done automatically. Second option is energy is distributed from plant to home or industries. Energy generation is done in distributed power plant. Next is bidirectional communication.
B. Answer is B.
What?
B. B. Energy distribution from plant to home or industry.
Okay. B. Anyone else? I'm repeating the question. Which of the following is true about traditional electric grid? Options are monitoring and restoration is done automatically. Energy is distributed from plants to homes or industries. C is energy generation is done in distributed power plants. D is bidirectional communication. Okay. So correct option for this is B, that is energy is distributed from plants to homes or industries. Next question is power monitoring along with asset management and optimal utilization falls under which characteristic of smart grid? Options are power system efficiency, real time pricing, distributed generation, power quality. Anyone?
A.
A. Power system efficiency. Okay. Okay. A. Anyone else? Power monitoring along with asset management and optimal utilization falls under which characteristic of smart grid? Options are power system efficiency, real time pricing, distributed generation, power quality. I've only got two responses. Others also please reply.
A. Power
A.
system efficiency.
Okay. Yeah. So A is correct option.
A.
Next question is which of the following statements are true about net metering? So statements are first statement is installation of smart meters does not contribute to net metering. Second is consumer are speed high on supply in excess amount of generated energy to do the grid during on peak hours. Third is in case of off peak hours the price is less. So options are statement 1 and 2 is true, statement 1 and 3 is true, statement 2 and 3 is true, and all the statement that is 1, 2, 3 are true.
Hello, ma'am.
Yeah.
This question is not clearly visible, ma'am. Can you please make it full screen?
Yeah, okay. Yeah. Is it visible now?
Yes, ma'am. Now it is clear.
Okay. Okay, so I'm repeating the question again. Which of the following statements are true about net metering? So statements are first one is installation of smart meter does not contribute to net metering. Second is consumer are speed high on supply in excess amount of generated energy to do the grid during on peak hours. Third is in case of off peak hours the price is less. So options are statement 1 and 2 are true, statement 1 and 3 are true, 2 and 3 are true, and all these 3 are true. Anyone?
D, ma'am.
D. All three.
D. D.
Okay. Anyone else? Only one response. Anyone else? C, D. Okay. So C is correct. So only statement 2 and 3 is correct. Next question is, which of the following is true about plug-in electric vehicle? Options are PEV does not rely on power plant to charge their batteries. Next is the consumer is discouraged by energy service provider to charge their batteries of PEV during their off-peak hours. Then by using electricity, the PEV does not reduce pollution. Then PEV can be utilized as an energy source during on-peak hours. D.
D. Those during on-peak. D.
Yeah. So D is correct option. So PEV can be utilized as energy source during on-peak hours. Next question is, what are the advantages of traditional operation centers? Options are, it tries to confirm that amount of energy generated is utilized. Grid voltage drop due to excessive current generation leads to unsteady grid. Third is controlling capabilities are not boundless, and fourth one is none of these. Okay. I'm repeating, what are the advantages of traditional operation centers? So it tries to confirm that the amount of energy generated is utilized. Grid voltage drop due to excessive current generation leads to unsteady grid. Controlling capabilities are not boundless, none of these. Anyone?
None of this, ma'am.
What? None of these. Okay.
From this.
Anyone else? D. Yeah, so none of these is the correct option for this. Next question is, avoiding unwanted current flow through grid is tackled by, options are demand side energy distribution by the grid, self-healing capability of the grid, energy serving in specific geographical location in smart grid, all of these.
B. B.
D or C? Can you please repeat what you said? D.
B, ma'am.
Okay. So all of these is the correct option for this. Next question is, select the correct order of evolution of industry 4.0. So according to first option, power generation and mechanical automation is the first, then smart automation, then electronic automation, and then industrialization. Option B is power generation and mechanical automation, then electronic automation, then industrialization, then smart automation. Option C is industrialization, power generation and mechanical automation, electronic automation, smart automation, and then smart automation. D is power generation and mechanical automation, industrialization, electronic automation, and smart automation at the end. D, C. Anyone else?
Ma'am, question, ma'am.
Question, yeah, I'm sure. Question is, select the correct order of evolution of industry 4.0. So according to option A, power generation and mechanical automation comes first, then smart automation, then electronic automation, and then industrialization. Option B is power generation and
D.
mechanical automation. Okay, D.
D.
D. Yeah, D is the correct option. So first of all, power generation and mechanical automation, then industrialization, after that electronic automation, and then smart automation. Next question is, Industrial Internet of Things is a network of physical objects, systems, platforms, and applications. These networks can interact with each other, external environment, but not with other peoples. Is this statement true or false? I'm repeating the question. Industrial Internet of Things is a network of physical objects, systems, platforms, and applications. These networks can interact with each other, external environment, but not with other people. Is this statement true or false? Anyone? A. So this statement
But
is
not with it. False. B.
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 This statement is false because in case of industrial internet of things, the interaction between machines is extensive and with people is limited, but there is interaction. So but according to this statement, there is no interaction with other people. So this statement is false.
False.
Next question is, which of the following design objectives are considered while using IoT devices for industrial applications? Options are latency, throughput, scalability, all of these.
D, ma'am.
D. All of
Yeah.
these.
D. D, ma'am.
Yeah. So we have to consider all these parameters, that is your latency, throughput and scalability. Next question is, intelligent transport system is least likely to render which of the following connectivity? Options are vehicle to vehicle connectivity, vehicle to sensor connectivity, vehicle to road infrastructure, vehicle to home connectivity. I'm repeating the question. Intelligent transport system is least likely to render which of the following connectivity? Vehicle to vehicle, vehicle to sensor, vehicle to road infrastructure, vehicle to home connectivity.
D.
D. Vehicle to home. Okay. Anyone else? D. Yeah. So D is the correct
Vehicle
option.
to vehicle.
What?
Uh,
What are you saying? Can you please repeat?
vehicle. D. Please D, ma'am.
Yeah, D is the correct option. Vehicle to home connectivity is least in case of your intelligent transport system. Next question is, intelligent radio modem can be connected to an IP serial device but not to non-IP serial device to extend the capabilities necessary for monitoring and communicating with other technologies. Is this statement true or false? Intelligent radio modem can be connected to an IP serial device but not to a non-IP serial device to extend the capabilities necessary for monitoring and communicating with other technologies. Is this statement true or false?
True, ma'am.
True. B. False. Others also please reply whether this statement is true or false. B. False. Okay. So two false, one true. Others also reply please. So this statement is false. Next question is, Wi-Fi, RFID and other wireless technologies can be utilized for preventing mining accidents. Is this statement true or false?
True, ma'am.
True. Okay.
True.
Others? A. True. Yeah. So this statement is true. Next question is, fill in the blank. Approximately around blank of the total data available currently in the world is unstructured. Options are 20%, 40%, 60%, 80%.
Sir, 80%, ma'am.
80%. Okay.
80%.
Okay. D. Others also please reply. I am getting only 2 or 3 responses. Yeah, so 80% of the data is unstructured. Next question is, in flow of data, after data generation and acquisition comes the storage of data. Is this statement true or false?
True, ma'am.
True. Okay. Others?
A. A, ma'am.
A. Okay. A. Okay. So can anyone tell me the phases which are involved in sequence wise? First one is data generation, then acquisition, then storage, and after that, anyone?
Analysis.
What?
Analysis.
Yeah, analysis. Right. Next question is, match the correct characteristic. Match the correct characteristic of big data present in the statement 2 with statement 1. So statement 1 is uploading 70 hours video to YouTube every minute. Then second is on average 30 millions of tweets per day. Then presentation of data in graphical format. Next one is most of the data being unstructured or semi-structured. And statement 2 is visualization, volume, variety, velocity. Now you have to tell that which one is visualization, what is volume, what is variety, and what is velocity. So options are, according to first option 1 to A, that is uploading 70 hours video to YouTube every time. A is visualization. So is this true? Okay, so tell me, these are the options. Tell me the final option. After that we will discuss. C. Okay, so 2 replies only. Others also please try. I've got only 2 replies for this question. Others also please try.
C, ma'am.
C.
C.
Okay. Yeah. So according to C, one is B. So first one is uploading 70 hours video to YouTube every minute. Okay. So according one is B, that is volume. Okay. On average 130 millions of tweets per day. So it will be your velocity to D. Okay. Then after that, presentation of data in graphical format. Then it is visualization. Fine. Then most of the data being unstructured or semi-structured, so it is variety. Yeah, so C is correct option. Next question is, state whether the statement is true or
Ma'am,
false.
please back the question. Back the question.
Okay.
Thank you, ma'am. Continue.
Okay. So question is, in smart grid, monitoring and restorations are performed manually. So you have to tell whether this statement is true or false.
False, ma'am.
False. Okay.
B.
Anyone else? B. False. Okay. Yeah. So this statement is false because in your smart grid everything is automatically done. Next question is smart home.
Ma'am, please back the question. Option. Continue.
Question number 17. Smart home uses the emerging smart grid technology to satisfy which of the following? Options are question is smart home uses the emerging smart grid technology to satisfy which of the following? Options are save energy, contribute to the smooth and efficient functioning of the electric grid, seek out the lowest rate, all of these.
D.
All of this. D. All of this.
Okay. Anyone else?
D, ma'am.
D. So D is the correct option. Next question is what are the benefits of using smart grid by the customers? Options are updated information on their energy usage in real time. B is single pricing option is there. Third one is disabling the smart appliances and smart devices from charging. Fourth one is all of these. I'm repeating the question. What are the benefits of using smart grids by the customers? First one is updated information on their energy usage in real time. Second one is single pricing option. Third one is disabling the smart appliances and smart devices from charging. Fourth one is all of these. A. Okay. B. A. So correct option for this is A, because in case of your smart grid, okay, so whoever has written D, so there is no single pricing option, there is dynamic pricing option in your smart grid. So according to the demand of electricity, the service provider can set the price of electricity, and you cannot disable the smart devices or appliances from charging. You can just increase the price of electricity, but you cannot forcefully disable the appliances from charging. So correct option is A only, that is there is updated information on the energy usage in real time. Next question is what is the full form of NAN? So options are North Area Network, Neighborhood Area Network, National Area Network, none of these.
B.
Neighborhood area network. Okay. Anyone else? B. Okay. Yeah, so NN stands for Neighborhood Area Network. Next question is
Ma'am, please repeat the questions.
yeah. So question is what is the full form of
Okay,
patient.
continue, ma'am.
Okay. So, question number 20th is state whether true or false. In smart grid communication, the gateway acts as a link between the smart meter and data aggregator unit. Is this statement true or false?
True.
True. Okay. Anyone else?
True, ma'am.
True.
A.
Yeah. So this statement is true. So basically, there are okay. So how many components are there? Smart meter, then gateway, then data aggregator unit, and then smart management system. Next question is what are the so question number 21st is what are the vulnerability that may exist in the smart grid? Options are physical threats, availability, dynamic system attacks, all of these.
D. D, ma'am.
D, all of these.
D.
Okay. D. So D is the correct option. So all these three are the vulnerability that exist in your smart grid. That is a physical threat, availability, dynamic system attacks. Next question is
Please back the question. Back the question, ma'am. Continue, ma'am.
next question is does the industrial internet of things follow a rip and amp a replace approach? Is this statement true or false?
False, madam.
False. Okay. Anyone else? B. So this statement is not true. Next question is match the following. So on the sensor side there is first industrial revolution, then second industrial revolution, then third and fourth, and their purpose is given. Then A is mass production, second is mechanized production, third one is industrial internet of things, and fourth one is industrial evolution and automation. So you have to match these. So according to option A, one is matched with B, 2 with A, 3 with D, 4 with C. B is 1B, 2D, 3A, 4C, 1C, 2A, 3D, 4B, 1C, 2A, 3B, 4D. Anyone? A. Others also please reply. Only one person replied.
Option A, madam.
Option A. It is 1B, that is so according to option A, one is matched with B, that is according to first industrial revolution, mechanized production, fine, 2A. Then second is mass production, third is your B, internet evolution and automation, and fourth is industrial internet of things. Yeah, so option A is correct. Next question is the implanted on body sensors on the patient's body have led to which of the following facilities? Options are better treatment outcome, reduction in cost, better accuracy in data collection. Fourth is all of these.
D.
All of this.
Okay. Others also please reply. D. Okay. So D is the correct option for this. So by implanting sensors on patient's body, you will get better treatment also. There will be reduction in cost and better accuracy in data collection. Next question is, which of the following is considered the primary challenge of IIoT? Options are managing a huge amount of data. Option B is environmental
Ma'am,
protection.
what is the full form of IIoT?
Industrial Internet of Things. Yeah. So, which of the following is considered the primary challenge of IIoT? Options are managing a huge amount of data, environmental protection, handling hazardous substances, none of these.
Primary hazard A. Managing huge amount of.
What?
A.
Repeat please. A.
Managing a huge amount of data.
Okay.
It's the primary challenge.
Okay. So some are responding B and B is so the correct option for this is A. So basically all are the challenges, but managing the data is the major or primary challenge. Next question is, which of the following which of the following are provided by intelligent transport system? Options are vehicle to vehicle connectivity, vehicle to vehicle
D.
connectivity. D. Others?
D. Ma'am.
D. So D is correct. Next question is, fill in the blank. Structured query language is mainly used for managing blank data in databases. Options are unstructured, structured, audio, all of these.
Structured query language. B. Structured language.
D
B.
or
Ma'am.
B?
B.
B.
B. Okay. Anyone else? B. Yeah. So B is correct option. So SQL is mainly used for managing your structured data in databases. Next question is, what
Ma'am,
are the
please repeat the question. Ma'am, repeat the question.
yeah, sure.
Okay, ma'am, continue.
So what are the advantages of the application of ML on IoT? Options are self-learner, increases human interaction, not self-guided, all of these. I'm repeating the question. What are the advantages of using ML in IoT? So it will make your system as self-learner, it increases human interaction, not self-guided, all of these. A. So A is the correct option. Next question is, which of the following represent the veracity characteristic of big data? Options are noise, abnormality, biases, all of these. D. Yeah, so D is the correct option. Next question is, state whether true or false. So no SQL databases can be used for storing unstructured data. Is this statement true or false?
True, ma'am.
True. Okay. Anyone else?
True.
So this statement is true. Next question is, what is a cyber physical system equipped with sustainable models of energy production, distribution and usage? Options are information and communication technology, grid, smart grid, traditional grid.
C. C, ma'am.
C, smart
C.
grid. Okay. Anyone else?
C.
Yeah. So C is the correct option. So this is the definition of smart grid. So smart grid is a cyber physical system which is equipped with your sustainable models of energy production, distribution and usage. Next question is, in traditional electrical grids, which of the following is done manually? Options are monitoring, restoration, both monitoring and restoration, neither monitoring nor restoration.
C, ma'am. C.
C, both monitoring and restoration. Yeah, so this option is correct. C is correct. So both monitoring and restoration is done manually in case of your traditional electrical grids. Next question is, which of the following is true for communication in smart grids? Options are one-way communication, two-way communication, three-way communication, four-way communication.
Two-way communication.
Two-way communication.
B. B. B, ma'am.
B, two-way
B.
communication. Anyone else? B. Anyone else? So there is two-way communication in your smart grid. So option B is correct. Next question is, smart grids help the
Ma'am,
customer.
please back the question. Back the question. Uh, Continue.
Next question is, smart grids helps the customer in reducing their power or electricity cost. Is this statement true or false?
True, madam.
True. Okay. Anyone else who wants to respond? Yeah, so this statement is
True.
So next question is, typically smart grid benefits which of the following participants? Options are consumer, service providers, stakeholders, all of these.
D. To all
D.
of these.
D.
Anyone who wants to explain how? No? Anyone how all these will get benefited from smart grid? Just one line.
It simplifies the work.
Yeah, to give little details that how consumer will get benefited not service provider, then how stakeholders?
Energy used is monitored by the customer.
What? Repeat, please.
There is mind the energy used at the real time price so that the pricing can be deducted by the consumer.
Yeah. Okay. So yeah. So next question is, what time is best suitable for
Please back the question. Back the question. Continue.
what time is best suitable for running smart devices in order to reduce electricity bills? Options are peak hours, on peak hours, off peak hours, does not matter.
I think time does not matter.
Time does not matter. Can you please explain how and why? Okay, so is static prices are there in smart grid or dynamic?
I think it's dynamic.
Dynamic. Okay, so if it is dynamic, then if you are going to charge your device or run your smart devices in on peak hours, then it will results in more bills, right? So in order to reduce your electricity bills, it is better to run your smart devices in off peak hours. Next question is, smart grids offer homogeneous pricing options to the customers. Is this statement true or false?
False, ma'am.
False.
False.
Yeah, false. We have just discussed that there is dynamic or heterogeneous pricing options available for the customers. Next question is, which of the following properties in smart grid covers load forecasting? Options are power system efficiency, distributed generation, power quality, consumer participation.
Distributed generation.
Distributed generation. Okay. Anyone else? Thirty-eight D.
Power quality. C.
C.
C, ma'am. Hmm.
Okay.
C.
So power quality is the correct option for this. Next question is, which of the following best represents the relation between IoT, and Industry 4.0? So according to option A, IoT is equivalent to your IIoT, and which is further equal to your Industry 4.0. Option B is IIoT is equal to IIoT is equal to IoT plus your Industry 4.0. Then C is IIoT is equal to the integration of Industry 4.0 and IoT. Then fourth one is it is the union of Industry 4.0 and IoT.
What exactly is the difference between B and C?
What? Can you please repeat?
What would be the difference between B and C? How do we interpret those answers?
What is the difference between what? I'm not getting. Can you please write in the chat box? Your voice
The
is breaking.
differ. How do I interpret answer B and answer C?
Answer B and answer C.
Mhm.
So basically summation means it is both considered as your, it can be considered as your IoT and Industry 4.0. So it can be IoT or plus means or symbol. It can be IoT or Industry 4.0, and this integration means it should be and, right?
Union.
So B and D can be considered as same, but B and C are different. So C is integration symbol.
Okay.
What's my point?
Okay.
Ma'am, IoT and industrial IoT, I understood. This is for the general purpose and this is for the industry purpose. Can you please explain that is Industry 4.0?
What is the difference between IIoT and Industry 4.0? This is what you are asking.
Hello? Yes, ma'am.
There is noise at your end. You are asking about Industry 4.0 and IIoT.
Yes, ma'am. IIoT, I understood that industrial Internet of Things, but I want to know about Industry
So
4.0, ma'am.
basically, in case of your Industry 4.0, what does Industry 4.0 means? It means the automation of your industry or enterprises. So in Industry 4.0, all those things that processing, your robotics, then analysis of data, then the communication between different sensors or machines can take place. However, your industrial internet of things, it just simply means the network of those machines
Ma'am,
that are
actually, another
communicating
one
with each
person's
other.
mic is on. Because of that, I'm not able to understand, ma'am.
What can you please repeat?
I think, ma'am, another one person's mic is on. Because of that, your voice is. I'm not
Okay,
able
okay.
to get
So
you, ma'am.
everyone please mute.
Ma'am,
Yeah.
what is the meaning of Industry 4.0?
Yeah, I'll tell you, but everyone please mute yourself. I'll tell what exactly is Industry 4.0, and after that IIoT. Okay. So first of all, Industry 4.0 means automation of your industry. So it consists of your all machines which are interacting with each other. After that, all the processing power the industries have, all the robotics, then additive manufacturing, all those things that is making your industry completely automatic. However, your industrial internet of things is just a sub part of that Industry 4.0. It is just the network of machines which are communicating with each other. So there might be some processing capability present there. There might be some analysis, or you can integrate this industrial internet of things with cloud in order to make your industry 4.0. Got my point?
Yeah, ma'am.
Yeah.
C
No,
is
ma'am.
the answer, ma'am. C.
No, ma'am. Something different.
What?
Uh, Please repeat this answer again, ma'am.
Okay. So basically, industry 4.0 means making your industries completely automatic.
Ma'am, 4.2, no, ma'am. 4.0, ma'am.
What?
Of Industries 4.0, ma'am.
Industry 4.0, 4.0 is same thing only. So industry 4.0 means
Actually,
making.
ma'am, it's no, ma'am. It's not be possible for the 4.0 industries. So that's why I'm telling you this.
What? Can you please repeat? Repeat, please. I'm not getting whatever you have said. Okay. So I'm continuing. So C is the correct
Okay, ma'am.
answer.
Continue this question.
Yeah.
फोर
So
पॉइंट
C.
इंडस्ट्री 4.0 का मीनिंग क्या है एक्चुअली?
इंडस्ट्री 4.0 का मीनिंग क्या है एक्चुअल में? दिस इज योर क्वेश्चन.
यस
हाँ.
मैम.
Making your industries automatic means it is industry 4.0. If your industry is completely automatic, okay, if the machines are interacting with each other, if the machines have the processing capability, if the machines
Ma'am,
are having
you mean making of industry in the automatic is known as 4.0 industry,
what?
ma'am? Making of making of
There is
industry in
too
the
much
automatic
noise in your
voice
end.
that
Can
is 4.0.
write your question in the chat box.
Rhea, can I
Ma'am,
ask you a
Industry
question on
4.0
IIoT,
has
please?
One by one, please. Okay, yeah. So you please, Shubhendu, please write your question in chat box. Your voice is not very noisy. Yeah, you can ask.
See, in one of the point, professor was saying that there one of the benefit being the upgraded scalability is a key point with the industrial 4.0.
Okay.
So I don't know if this professor really meant or this is my understanding. So what I understood was
Hmm.
everything would be virtualized, is what I understood.
Okay.
So,
So in case of
so,
Industry 4.0, everything should be virtualized. This is what
huh,
you understood.
this is what I understood. So, if it is virtualized, then it could be scaled up very easily. This is what I understood. Is my understanding right or wrong, please?
Virtualized is the same concept. Virtualization concept is the same as you taken from cloud, or is it different here?
I tend to think it is something like the Blink, you have a virtual sensor using a Blink application. That is what I am assuming.
See, it is not always possible to make everything virtualized, right? So in
Correct.
some case, yeah. So in some cases, if that scenario is not possible, then scalability is the one of the major issue. So it is difficult to handle that much amount of devices at the same time. So scalability means to handle the large number of devices at the same time.
Okay, I think I got what I wanted. Thank you. Thank you so
Yeah.
much.
Yeah. So Shubhendu, what was
Then
your
scalability means what, ma'am?
yeah?
Ma'am, what is the meaning of scalability? What is the meaning of scalability?
Scalability means your network or your system should be able to handle the large amount of devices at the same time.
Uh, Handle more large number of
Devices,
what, ma'am?
devices.
Large number handle my devices is able to handle a large number of devices.
Your
Okay, ma'am.
system should be able to handle large number of devices.
ओके मैम मैम वो जो इंडस्ट्री 4.0 का मीनिंग फिर से बताएंगे
इंडस्ट्री 4.0 के क्या?
इंडस्ट्री 4.0
Industry 4.0 means making your industry automatic.
अच्छा ओके मैम
Next question is, which of the following best
मैम प्लीज बैक द मैम प्लीज बैक द क्वेश्चन अब आंसर्स
should I continue?
यस मैम कंटिन्यू
Which of the following best represent industrial internet of things? Options are consumer IoT, enterprise IoT, industry 4.0, none of the above.
Internet of 4.0.
Industry 4.0. Oh, what are you saying? Can you please repeat?
Yes, ma'am. That is the industry.
B, ma'am. B.
B or D?
B.
B. Enterprise IoT. So industrial IoT means your enterprise IoT. Next question is, IIoT includes machine-to-machine communication. Is this statement true or false?
True only.
True. Okay. Anyone else?
A. True, ma'am.
A. True. Yeah. So this statement is true. Next question is, fill in the blank. IIoT.
प्लीज बैक द क्वेश्चन
Fine.
कंटिन्यू
Yeah. IIoT is based on blank approach. Option A is wrap and reuse, rip and replace, wrap and replace, wrap and reuse. So
Option A, madam.
A, ma'am.
A, wrap and
A.
reuse. Anyone else? Okay. So A is the correct option. Next question. Yeah, what are you saying? Okay. Which of the following may be used to describe IIoT? Options are mechanized production, mass production, internet evolution, and automation. None of these.
Option C, madam.
Option C. Okay. Anyone else? C. Others also please reply. Which
C.
of the following may be used to describe IIoT?
C.
Mechanized production, mass production, internet evolution, and automation. None of these. So,
C.
internet. Yeah. C. Internet evolution. Okay, I'll check this question because automation is there, so it should be C.
Internet evolution and
Yeah.
automation.
So I think this is incorrect question. Next question is typically how many types of data exist? Options are 1, 2, 3, 4.
Structure.
Structure and unstructured, two types.
Two types. Okay. Anyone else? Yeah. So correct option is 2. Next question is which of the following?
Please back the question, back the question. Continue, ma'am.
Which of the following V's in big data refers to quantity of data that is generated? Options are volume, velocity, veracity, value.
Volume, madam.
Volume. Okay. Anyone
Yeah,
else?
volume, ma'am.
Yeah. So volume is the correct option. So yeah, these were the questions. So okay. Now yeah, so I'll again make announcement next week. We will have two sessions. First one will be on Friday at the same time, that is from 6 to 8, and the other one will be on Saturday from 5 to 7. So
Uh,
on
Ma'am,
yeah,
ma'am,
huh.
ma'am, please send me the week 9 and week 10 PDF.
Yeah, I'm just sharing.
yes, ma'am. I have one doubt
Yes,
also.
ma'am.
The next week will be the last class, now, ma'am.
Yeah,
Friday
that's
and Saturday before exam. That is the last two classes which we will going to conduct on
yeah,
Friday and
right.
Saturday. Okay.
Yeah, so on Friday we will discuss about the topics of week 12, and after that same questions
Saturday
of week 12, and on
total.
Saturday the questions from week 1 to week 12. So these questions were not same. I will make other questions or take questions from the previous assignment questions. So yeah, so on Saturday we will discuss around some 100 or 120 questions. So
Okay,
Saturday's
ma'am.
class is important. Okay.
Ma'am,
Okay,
ma'am, please
thank you.
send me the 9 and 12 PDFs.
What? Yeah, I'm sharing.
We'll download.
Give me 2 minutes. I'm sharing.
Ma'am,
Yeah.
hello, ma'am.
हाँ बोलो बोलो.
Please tell me the what is the meaning of scalability.
What?
Scalability means.
Repeat. I'm not getting. Write in the chat box. So this is the link. I will upload week 10, week 11 also. So we till week 10 I have already uploaded. After this session I'll upload week 11's PDF also. Shubhendu, what were you asking? What is the meaning of scalability? So scalability means that how many devices your system is able to handle at a time. So your system is scalable if it is able to handle large amount of devices at the same time.
Many system, how many?
Devices
Ma'am,
able to handle.
how many devices
Your system
is able to have?
at a particular time.
Your, your system is able to handle.
Right.
Able to handle. Ma'am, hello,
Yeah, yeah.
ma'am,
Hmm.
please tell me what is the shift point
What?
industry 0?
Industry 4.0. Industry 4.0 means making your
Yes.
industry automatic.
Hello.
Yeah. Anything else you want to ask? Yeah, I have uploaded week 11 also, so you can access the PDF from the link which I have given to you. Okay.
Ma'am, please upload week 9 and week 10.
Yeah, all
Hello.
PDFs are there only. So from week 1 to 11, all PDFs are there in the link.
No.
Okay, so okay, we will meet on
Yes.
next Friday again. So thank you.
Thanks so much, madam.
Thank you and have a productive weekend.